Hey guys, this is Camplified, and in this video we will discuss Wolff-Kishner reduction reaction. Now this is a reduction reaction from the topic aldehydes and ketones. In this particular reaction we will convert aldehyde and ketone to alkane. Right, so let's start with the reaction. The reaction involves basic solution of hydrazine as the reducing agent. So the reaction that we will discuss the mechanism of is R or R1 C double bond O R2 in presence of hydrazine, that is NH2NH2, and NaOH strong base will give alkane as RCr2 hydrogen and hydrogen. This will give you, this is your Wolff-Kishner reduction. Right, now let's move for the mechanism. So it is a three-step reaction. First one is formation of hydrazone when ketone react with hydrazine. Before we start the mechanism, remember a few things, that in our example we have taken ketone, but in place of R1 and R2 you can either take aryl group, alkyl group, or hydrogen. That is, you can also make it aldehyde, and we are doing the mechanism for ketone. Now there will be no effect on these two groups. Everything in the reaction mechanism will take place at this particular area, carbon and oxygen bond. All right, so these groups will remain as it is. First thing. Now in the reaction, hydrazine is present. Hydrazine is present as a nucleophile. NH2 have two lone pair of electron present on both the nitrogen, so this act as a nucleophile. Now if by chance there is OH minus ion in the mechanism, then it means we have obtained this OH minus ion from NaOH, right? And if there is a H plus ion, if we need H plus ion, we will get it from our water molecule. All right, so if any of these things come into play in the reaction mechanism, don't think from where they are coming, because I have already told you that these things are available in our reaction and we will use these things according to our necessity or our requirement, right? So now let's start the first step of reaction mechanism of Wolff-Kishner reduction. Now we know that carbon now have a delta positive charge and oxygen have a delta negative charge. As soon as carbon acquires a positive charge, the lone pair of electron will attack the carbon of hydrazine and the double bonded electrons will move towards oxygen. And the product that you are going to get is R1 C R2 O negative, and look carefully what we are doing right now, H and H2. Now since nitrogen has four bonds in this place, so we have to put a positive charge on nitrogen. Now what happens in the next step is, this bond will break and provide the electrons to nitrogen, and the H plus ion so created will attach to the oxygen, giving us R1 C R2 OH NH and NH2. Right, this is the first step. Now what happens in the next step? Now the lone pair is also there. The lone pair of nitrogen is back to it because the donation of electrons from breaking of hydrogen and nitrogen bond, right? Now what happens in the next step is, these electrons will make bond with carbon and these electron will transfer to OH minus or OH group. So in the next step what you are going to get is, OH minus will be released, right? And you will form a double bond between nitrogen and carbon. So R C R2 and a double bond between carbon and nitrogen and NH2, right? Or we can write it in some other way. Let me write it properly and let me move it a little bit. We can write it as R1 C R2 double bond nitrogen and NH2. Two hydrogens are present on the terminal nitrogen. Now since this nitrogen is making 4 bonds, we have to put a positive charge, right? After putting the positive charge, we can move to the next. What happens in the next step is the OH minus from the strong base will attack. Sorry, there is one more nitrogen. Let me rub it. We have only removed one hydrogen, right? There is one more hydrogen at this place. So what this will do is this will attack. OH minus will attack the hydrogen atom and you will get the product as R1 C R2 double bonded nitrogen and NH, right? Now since hydrogen is removed, lone pair will be present on the nitrogen, right? This time lone pair will be present on the nitrogen. Now the product that you have received at this place is your hydrazone. This is your hydrazone. This is the same product which we were talking about, formation of hydrazone. Formation of hydrazone. We have completed the formation of hydrazone in the first step, right? Now let's move to the second step. In the second step, what is going to happen? Deprotonation of terminal hydrogen. Deprotonation of terminal hydrogen by strong base followed by double bond formation with the neighboring nitrogen. The two nitrogens present will form a double bond in this step, right? So let's first draw our hydrazone. R1 R2 double bond N NH2. Now OH minus from the strong base will attack one of the terminal hydrogens. H2O will be removed and you will get R1 C R2 double bond N NH, and this nitrogen has a negative charge because of presence of two lone pair of electron. Now what this will do is it will transfer its electron between the two nitrogens and this double bond electron will transfer to carbon, giving a negative charge. Next what happens is R1 C R2 and double bond NH, right, and a negative charge. Now what happens in the next step? From HOH, that is our water, we will obtain our proton, and this proton will attack the carbon to give R1 C R2 N double bond NH, and a hydrogen is now attached to the central carbon, right? This is our second step. This is our second step. We will include this step in third step also, right? So this is our second step, formation addition of proton to the central carbon. Now let's move to the next step, or the third step, or the final step. Protonation of carbon. We have already done that. Protonation of carbon by water molecule followed by deprotonation of terminal hydrogen and release of nitrogen gas. Let's take a look at these steps. First, let us draw our carbon, central carbon with a negative charge, and double bond NH and a negative charge. Now in this step, OH minus ion will attack the carbon, sorry, the HOH, water will provide the proton, and you will get this product R1 C R2 and double bond NH and hydrogen is now attached to the carbon. Now the next step is very important. The OH minus will now attack the terminal hydrogen. Let me just make it clear. It is like this. The terminal hydrogen is attacked by OH minus ion, and this bonds, the electrons present in the bond will be transferred to neighboring nitrogens, and this bond will transfer to carbon atom. And what you are going to get is R1 C R2 H, a negative charge on carbon, plus H2O and plus N2. Nitrogen gas is released. In our definition we have already talked about it. So this is your nitrogen gas which is going to get released. And in the last step, what is going to happen in the last step? In the last step, water will provide the proton and will be taken over by carbon negative charge. You will get R1 C R2 hydrogen and hydrogen. This is your alkane. This was your mechanism of Wolff-Kishner reduction reaction. These were the 3 steps. You can watch them again in the same video. This will be it for today's video. Thank you very much for watching.